all these properties, often a monopoly is an extremely useful starting point for thinking about a broad range of issues with market power. So, for example, one basic intuition that comes out of the monopoly model is that whenever a firm faces, whenever a firm's good gets more elastic, it's going to increase its quantity produced. And so what that says is, unlike in a competitive market, a firm that now faces a new competitor might actually increase quantity rather than decreasing it. Why? Because if their demand becomes more elastic, that could outweigh the reduction in the quantity of demand. Right? Another example of that might be, so the traditional analysis suggests that demand functions are more elastic in the long run than in the short run, right? So you would naturally think that if there's a good, let's say like heroin or something like that, which is much more elastic in the long run than in the short run, a monopolist that controls the market will produce a lot more in the long run than they will in the short run. What does that mean? So in the long run, they face a more elastic demand curve that will even produce more. That means if they expect to maintain their monopoly for a long period of time, right, they're actually going to produce more and have a more competitive price than if they only expect to maintain their monopoly for a short period of time. So even when there are issues related to competition that come in, there's a lot of things that just the incentives of a single firm help us analyze. Okay, so now I want to start thinking about the comparative statics rather than just the level of monopoly prices, right? So probably like the most common thing that the competitive models are used for is to think about things like what's the incidence of the tax or the shift in demand or something like that. How does that cause things to change? So a natural thing to do to start thinking about monopoly comparative statics is to think about what's the effect of the tax on a monopolist. And just to review, let's think about how we do this in the case of competition. So in competition, price is equal to marginal cost. The tax raises the marginal cost by a unit. So we can derive the effect that a tax has on price by using the implicit function theorem. And we get this expression here that the derivative of price with respect to the tax is equal to how much the quantity changes in response to the tax, which is 1 over the derivative of P minus MC, times how much the price changes when the quantity changes, P prime. And rearranging this, we get this formula, the famous incidence of tax formula, that the increase in price in response to an increase in the tax is equal to 1 over 1 plus the ratio of the elasticity of demand to the elasticity of supply. Now, under monopoly, it's marginal revenue that's equal to marginal cost, not price that's equal to marginal cost. And so the incidence formula is the price derivative of price over the derivative of marginal revenue minus marginal cost, rather than the price minus marginal cost. And that rearranged gives us this formula. So everything here is old, you see, except for one thing. So you see, that's just the classic term, right, from the perfectly competitive formula. These are just additional things that depend on elasticity of supply and demand. But the really crucial part is here. So this is what's called the super elasticity of demand. That thing with the line over it is the super elasticity of demand. And the super elasticity is defined as the elasticity of the elasticity. By what percent does the elasticity change when the price changes by 1%? Now, this bottom part of this expression here always has to be strictly positive if the second order conditions are satisfied. In fact, that bottom is exactly the second order conditions for the monopoly. So the pass-through is always going to be positive. But what intuitive property of the demand curve does this superelasticity correspond to?
Sorry?
What intuitive property of the demand curve does the superelasticity correspond to? Yeah, exactly. So this is how the elasticity of the demand curve changes as you move along the demand curve. If the superelasticity is positive, that means that as you move up the demand curve in terms of price, it's getting more elastic, right? Yeah. And that means that the demand curve is concave, or less convex. If it's small or negative, that's going to mean the demand curve is very convex, right? And this is sort of the key additional element of monopoly, and we sort of saw this in those earlier diagrams I was showing you, which is that the relationship between the marginal revenue and demand curve is determined by the curvature, and we're picking that up exactly here by this superelasticity. Now, note that when the demand curve is very elastic, when the demand curve is very elastic, this term disappears, this term disappears, and this term gets very large, so we're basically left with something that's just like the perfectly competitive case. So when demand is very elastic, things are basically as the formula for perfect competition would suggest. So that's a sense in which there's an agreement between the perfectly competitive and monopolistic analyses of pass-through. However, when demand is not so elastic, it's going to be very important what the curvature of demand is. The more concave demand is, the smaller pass-through is going to be. The more convex demand is, the larger pass-through is going to be. But then there's also, of course, the component that comes from the standard perfectly competitive analysis, which is that if the supply curve is inelastic, then that's going to tend to lead to small pass-through, right? If the supply curve is very elastic, that will lead to larger pass-through. And in fact, if the supply curve slopes down, if there's economies of scale, that's going to make the pass-through very large. And in fact, if the marginal revenue curve slopes up, or relative to the demand curve at some point, the second order condition can fail to be satisfied, that bottom thing can fail to be positive, and then that'll mean that there will be an infinite pass-through over some range, that there will be a discontinuous jump in prices with a cost change for a small amount. And I'll actually show you a real-world example of that in a moment. Okay, so if we continue to impose a tax on a monopolist, that's going to continue to reduce the quantity she's going to want to sell, and thereby raise the price in the market, right? And what that means, if you think about it, is if we keep raising this tax and eventually nothing is sold in the market, once nothing is sold, nobody's earning any surplus. Neither the monopolist is earning any profits, nor are the consumers earning any surplus, right? And so we can sort of measure out the total surplus that the consumers and monopolists earn at equilibrium by adding up the surpluses that they lose as we impose these taxes. And that allows us to connect the pass-through rate to the the pass-through rate to the division of surplus between the monopolist and the consumer. Yeah?
Can you add the tax that you're generating? So, I don't know, because they're not letting you do it.
Yeah. Okay, so Andre Pulcheria, how much, when I raise the tax by 1 unit, does the monopoly's profit fall?
Take the derivative. I got it by heart.
Well, no. So there's a very simple argument based on the envelope theorem, right? So the monopolist, can anyone have an idea? Who? Well, one for every unit he sells, right? Because he pays the tax on all the units, because we can treat it as if his price is held fixed, because he chose price to maximize his profits, right? So these profits fall by exactly the negative of the quantity, right? Sarah Gordon, how much does consumer surplus fall when the tax is imposed? Well, that's what gives you the part of the triangle argument, and that's how much social surplus falls. But what about consumers? So how much, when prices rise by $1, how much does that hurt consumers? Anyone else want to jump in? Come on, when the price of a good rises by $1, how much does consumer surplus fall by? It falls by the quantity, right? If the price rises by $1, the consumer surplus has to fall by the quantity, because by the envelope theorem, we can assume that the consumer keeps her purchases constant as the price rises, right? So the amount that consumer surplus falls is how much the price rises, right, for every unit of tax, times the quantity, which is exactly the negative of the quantity times the pass-through rate. Right? And so what does this tell us? This tells us the ratio of how much consumer surplus falls to how much monopoly profits fall is exactly the pass-through rate on the margin. Right? And so what that tells us is the ratio of consumer surplus to monopoly profits is exactly equal to the average of the pass-through rate weighted by quantities over the tax rates between 0 and infinity. So that gives us the following formula. The ratio of consumer surplus to profits is the average pass-through rate. Now you can use a similar argument under perfect competition, right? So when we impose a tax on a perfectly competitive industry, how much of that is borne by the industry? Well, remember that if the industry is perfectly elastic, they bear none of the tax, right? So if the pass-through is equal to 1, right, then they bear none of it. If the pass-through is, if it's perfectly inelastic, they bear all of it, right? And if it's somewhere in between, they bear 1 minus the incidence of the tax, right? And so the profits fall when the tax is imposed by 1 minus the pass-through rate. And so the ratio of consumer surplus to producer surplus in a competitive industry is the ratio of the average pass-through rate to 1 minus the average pass-through rate. And so, more generally, if we use lambda as an index of competition, where 1 is perfect competition and 0 is monopoly, it's natural to expect that the ratio of consumer surplus to profits is going to be the average pass-through rate over 1 minus lambda times the average pass-through. Okay. So pass-through is also going to determine how firms respond to change. Yes, sorry, go back for a second.
Yeah, is that sort of your definition of a lambda, of measuring competition or monopoly power, or does that sort of come out of a model of which those two are special cases of lambda 0 and 1?
Yeah, so this is just something I made up. I actually haven't proven anything related to this. This is a conjecture. I'm sure there's some way to define lambda relative to other potential definitions of competition such that this is true. The question is whether it corresponds to anything useful or interesting. But my guess is that it probably does. But